So today we will continue from the yesterday topic. In today's topic, we try to see about 2 to 3 topics. The first one is how you can write late expression in MeTTa. So try to follow and write the codes with me here. We will see how you can define your function using MeTTa, how you can start function that receive a parameter, function without parameter, and then we will see how recursion works. I hope you guys are already familiar with some recursion functions like factorial. So you know how factorial works in your mathematics course. We will see how we can code recursion using MeTTa, and finally we will see some kind of higher order function, like it's a little bit more advanced version of recursion, but you will get these topics when you study more on functional paradigms. So we will cover this topic, and then there are some challenges you guys try. So for the morning session, we try to see late expression and the function. Then in the afternoon, we will see recursion. Then we will do some challenge, okay? So everyone is ready, right? Okay, very nice. So the first one is late expression. If you guys are already familiar with JavaScript, you might hear the later. So here, for example, you can write this expression into your VS Code, and you can try to run the code, and you can see what the result looks like. But before that, this is a very simple expression. What we are trying to say here is that we are saying store this expression into X variable, and we want to output, or we want to return X. So we stored this is X value into X, and we want to return X. So for example, if we run this code, you can see that in the output section, this is X value. So this is a very simple late statement. You can change this, like for example, you can write another late statement. Late X can be, let's say, it is 1 plus 2. And we are executing some expression here, and we want to return the value, which is X. So now let's run again and try to see what the output looks like. So here, as you can see, we are getting 3, right? So this is very simple statement. There is no complicated thing. Here, inside this expression, we put the expression we want to evaluate. Then MeTTa help us by storing the result into X. Then we will return X. Maybe we can attach X with some statement. For example, the result is X. The result is X. let's run now. The result is 3. So very simple, right? So now, by now, you guys should understand what the late expression looks like and how you can use it. The other thing is function. If you guys take an introduction to programming, you already know what functions are, how you can write functions in different programming language. So in MeTTa, to write function, we do we open expression and we start from the equal sign and we open another expression and we give the name of our function. For example, let's say our function name is maybe function name, and we open another expression and we write here the thing that the function we want to return. So this is the function I want to return. So this is a simple function definition in MeTTa. It's very simple. We start from the equal sign by opening expression. We give the function name. We open another bracket and we write our this is the function body. So we call our function using my name. Okay, I'm having trouble with naming a function. Let me say the function name, my function name. My function name, so we already called it here. So let's run and see the value. This is the function I want to return. So this is the return value of my function name function. So after we define our functions using this kind of structure, we call it using the exclamation mark, then opening, and then finally calling or inserting our function name. Very simple, right? Is there anyone who has any questions regarding the function definition? By now, you should be able to define your own function. You can write the body of the function and so on. Okay. So these examples are more to show you the body structure of how we can define function. But for example, let us see how to write a function that detects whether a number is even or odd. That's basic functionality of some simple functions. So for example, we have is-even function here. So now, before showing you the is-even function, for example, in your introduction to programming, function receive parameter, right? There are functions that receive parameter. So how do we pass a parameter for our function? So in MeTTa case, it's very simple again. What we do is that we start from opening to our expression, then use equal sign. Again, we open another expression. We write function with parameter. This is our function name. So to give or to make the function to receive a parameter, we just give him some variable. So the $x is a variable in MeTTa. So this means this function receives one parameter. And if we want to make it 2, we can continue like y. So now this function receives 2 parameters. For now, we want our function to receive 1 parameter. And now let's continue to the body of the function. Now we say this is a parameter we received from the user. So we pass x. So as you can see, like MeTTa is not like other programming language. Of course, we use strings to write these kinds of English statements, like in print, in the case of Python. But in MeTTa, everything is symbol, so it will treat these English statements as a symbol. So that's why we are writing simple English in our function body. Now we completed defining our function. Now let's call our function. So anyone who tell me how I can call the function? Anyone? Function? Underscore parameter? Like this?
No.
You mean bracket? Okay.
Function underscore parameter.
What shall I do now?
Function func underscore.
Okay.
Underscore.
Okay.
Parm.
Okay.
And an argument you can pass.
I can pass what?
A number integer.
Okay, a number. Very, very good. So now this is how I can call my function. Very simple. So let's execute the code. Here you can see that this is the parameter we received from the user, 4. So we get our result. So we know how to define a function. We know how to pass a parameter for our function. We know how we can construct the body of the function. Okay, very simple. Now we will see some real functions. Like, for example, we use isEven function when we write some code. We even use this function later on. So guys, try to see how isEven function is defined, and it's very simple. We start from the equal sign. We give our name of the function. So we want this function to receive a parameter, and now we go to the body of the function. So what we are doing here is that we are saying that the modulo of x over 2, if it is equals to 0, we say or we return true. Otherwise, it's false. Is this clear? Any question regarding how the isEven function works? So it's very simple function. Now I want you guys to write isOdd function. Sorry? Yes. So to do, for example, like if you want to compare two numbers, for example, 2 and 3, this returns you. This is saying like it returns a boolean, and it's comparing 2 and 3. Since 2 and 3 are not equal, it returns false. To do not operation, we do this kind of operation. Let's output and try it. I should check what the not equals to operation looks like, but I think in the case of, for now, I think you can do like not. You can use like this, hopefully. Yes, it's working. So to reverse this equal sign, you can use the not operation. So turn this function into isOdd function. IsOdd function. So for now, try isOdd function, and after I will check your function. In the afternoon, we will try to see recursion operation starting from the factorial operation. Then we will see other two functions like filter and fold function. So these are like cool functions. You can see how recursion works. So continue with this exercise. So there are also other exercises, like I will share you this code base inside the Telegram group, and you can go in this challenge section, and you can start to do some exercises. So at the end of the week, we have prepared some rewards for students who do more exercises. We have also project challenge you guys can try. So that also counts. So since today we already covered functions, late expression, in the afternoon we will see recursion. There are related challenges in this folder. You can try to solve them starting from what you guys already learned. And the person who delivered the solutions, we'll get something. Okay, for now, try is-odd function, and we will wrap up the morning session.